We now know how to find the area of rectangles. What I want to do in this video is think about how we can find the areas of triangles. So we're starting here with a right triangle. It has a 90-degree angle right over here. Right triangle ABC. And let's think about how we can find its area. Well, maybe we can construct a rectangle out of triangle ABC, and if we can construct a rectangle out of it, and then maybe we can somehow find our area of part of that rectangle. And the best way to construct a rectangle is to really duplicate ABC and then flip it over and put it right on top of this. And just to verify that that definitely will be a rectangle. So we know that this is 90 degrees right over here. Let's say that this is x degrees right over there. We have x plus 90 plus this thing have to be equal to 180. So this thing and this thing have to add up to 90. So let's just call this 90 minus x. Now let's flip this thing and rotate it around so that it will look like this. So then you would have another triangle that would look just like this. Where now this right angle on the flipped version is that right angle right over there. This angle right over here, this x, is now this angle right over there. And this 90 minus x is now this angle right over there. And you can see x plus 90 minus x, that'll give you a right angle. And then you have x plus 90 minus x, that gives you a right angle. And you have 4 sides and 4 right angles. You are definitely dealing with a rectangle. And this rectangle has 2 of our original triangles in it. So we can write that the area of triangle ABC, that's what the brackets mean, area of triangle ABC, is going to be equal to 1/2 times the area of our entire rectangle. And our entire rectangle, let me add another point here. Let me call this D. It's going to be 1/2 the area of rectangle ABCD. And we know how to find the area of rectangle ABCD. It's going to be equal to the base of the rectangle. So this is going to be equal to 1/2 times, and so this part right over here, let me do this in a different color. The area of ABCD is equal to the base, or the width, of the rectangle. So that's just the length of BC. I'm just putting this in parentheses. It doesn't mean, BC is just the length of this segment right over here. And I'm just putting it in parentheses so that we don't get the letters jumbled up. So it's going to be this width, or this base right here, times the height of the rectangle. So times AD, times AB. So it's this base times this height gives us the area of the entire rectangle. And the area of our right triangle is half of that. So there we have it. It's 1/2 times this base times this height is the area of a right triangle. So in general, if you ever have a right triangle, and this is a right angle right over there, which is, you need one right angle in order for it to be a right triangle, and this base has length b, and this side over here has length h, you know that the area is going to be equal to 1/2 times the base of the triangle. That's the base of the triangle, BC, times the height of the triangle. So you could view it this way if you look at the actual letter points, and if you just view these measures as the base times the height, it's just 1/2 base times height. And we only know that this works right now for a right triangle. Now let's think about it for other types of triangles that aren't necessarily right triangles. So here I have a kind of an arbitrary triangle, ABC. And to approach figuring out its area, what I want to do is just split this up into 2 right triangles. So what I'm going to do is drop a perpendicular from B. So I'm going to just literally, if this was an actual structure, you just literally drop something straight down from here. And that line is going to be perpendicular to this base right over here, to AC. And let me call that point D. And what's useful here is now we've turned that one triangle into 2 right triangles. So we can say that the area, let me write it this way. We can say the area of triangle ABC, that's what we want to figure out. It's equal to the area of this character right here. So it's equal to the area of triangle ABD, plus the area of triangle, plus the area of this magenta triangle. So plus the area of BCD, And this is useful because we know how to find the area of right triangles now. And obviously, if this is 90 degrees and this is also going to be 90 degrees, the area of ABD is 1/2 base times height. So it's going to be 1/2 times the base, which is the length AD, So 1/2 times AD times the height, which is the length of BD right over here, assuming that we can figure that out. So this times that length. So BD. So that's the area of the blue triangle. And now let's find the area of the magenta triangle. Well, once again, it's a right triangle. It's going to be 1/2. I want to do that in magenta. Let me do that in magenta. So it's going to be 1/2 times the length of this base right over here, which is DC, the length of segment DC, times the length of BD again, times the length of BD again. Now, you can factor out a 1/2. We can factor out a 1/2 BD from both of these terms. 1/2 BD, so you get 1/2 BD, 1/2 BD times AD. We're left with AD, and that's not the same shade of blue. We're left with AD plus DC, plus DC, plus DC. Let me close the parentheses. And what is AD plus DC? AD is the length, that length, and then DC is this length. So if you were to add up those two lengths, you get the length of AC. So this whole thing is the length AC. So we're left with the area of ABC is equal to, I'll do this in a new color, it's equal to 1/2, and I'll just switch the orders right over here. 1/2 times, actually let me write that same color, times AC, AC times BD, times BD. Now what is this again? Well, this is now 1/2 times the base, which is this AC, times the height, which is BD. So that's pretty cool. It worked for right triangles, and it actually, if we know the height of a triangle, notice this isn't one of the sides now. For a right triangle, it was one of the sides. Now for this arbitrary triangle, it isn't. But if we know it, the area of this triangle is still 1/2 times the base times the height. Now what about a triangle like this? How can we figure out its area? Well, let's try to do it the same thing. Let's see if we can somehow either construct this out of right triangles or maybe add a right triangle of this to make it into another right triangle. And the easiest way to do that is we could kind of just drop a rock from right over there. And then this, and then where it kind of hits the ground would form a right angle. And let's call this point D. And what we care about, what we want to find in this, what we want to find the area of, we want to find the area of triangle ABC. So that's what we care about. Triangle ABC is what we want to find the area of. But the area of triangle ABC is going to be the area of this larger right triangle that we've set up. It's going to be this larger triangle. So it's going to be the area of ADB, ADB, minus the area of the smaller triangle, minus the area of this smaller one right over here. So minus the area of ADC, of ADC. So this blue one, ADB, this is just the whole thing. This is the whole thing, just so we're clear about what we're talking about. Now, what is the area of ADB? Well, we know how to find the area of right triangles. ADB, area of ADB is going to be 1/2 times our base, which is DB, DB, the length of segment DB, times our height, which is the length of AD, times AD. And then from that, we want to subtract the area of the smaller triangle. So that's going to be 1/2 times our base, which is DC, that's the length of our base, DC, times the length of our height, which is AD, AD. So here we can factor out a 1/2, and we can factor out an AD, a 1/2, and an AD. So let's do that. So we factor out a 1/2 times AD, and what's left inside is a DB, DB minus a DC, minus a DC. Now what is DB minus DC? Let me put the parentheses in white again. So we have DB minus DC. Well, if you take the length, DB is the length of this whole thing, you subtract from that the length DC, you're going to be left with CB. So this character right over here, this is CB. And so the area of ABC is going to be equal to 1/2 times CB. I'm just switching the order of multiplication. Let me do that in that yellow color. 1/2 times CB times AD, times AD. Now what is this? Once again, it's 1/2 times our base times our height. And once again, the height in this case, because it's not a right triangle, it's not one of the sides. Someone would have to give you that information, or you'd have to figure out what this actual height is. But what's neat is, in any form of triangle, the area is 1/2 base times height. The height is kind of, if you have the sides of a right triangle, it's easy to figure out. For these others, if it's not given, you might have to do it in some tricky way, figure out the height somehow. But anyway, hopefully you found that useful.